So, this is the third video in the series, and so far I have introduced the project Chamber, which you can still find here, and I have talked about setting the expectation. I have written about CLI and options, and we just created the happy flow for the new option in Chamber. Right. We haven't worked on anything else yet, but we reached the point where we are creating the chamber file, and we are accepting the password input, and we are able to hash it primarily, and we are able to save it in the chamber file. But that's about it, right? And the next command I want to implement is cp. Like, I want to be able to copy a file from my hard disk or the host fs file system into the chamber file that I have just created. That's the next step. And for that, we need to define the data storage format. Now, in the beginning, I said that I don't want Chamber to be dealing with raw devices. Instead, I want to use Chamber as something that exclusively works with vault files instead. And given that, I need to find out a way of storing all the encrypted files into the Chamber file, which is the vault file that will be created by Chamber, the tool. So I had to come up with some way of storing the data that Chamber should be able to read, right? And it has got a different set of requirements because of how different it is from the existing tools, right? So if you look at the existing tools, if you look at obviously OpenSSL and GPG, they usually work with single files. GoCryptFS works with a mapping of every file being stored on the disk in an encrypted format, and the rest, BitLocker or Lux or encrypted DMG, they already define a file system understood by the operating system where you are creating them. Crypt also wants you to create a file system, and file system is not something I want to implement into Chamber. I don't want to recreate the exFAT file system in Chamber so that it's readable everywhere and so on. Not only this, I also want Chamber files to be splittable, and that those things pose a challenge. So this article here is more or less the thought process and the result of my thoughts on how I'm going to store the data that I want to put in a Chamber file. So I've written my thoughts, and I am just going to read through it. I hopefully will also explain a few things in the process. Alright, so let's start. If you look closely, you'll find that everything that was talked about in setting expectations for Chamber revolves pretty heavily around creating the vault file. If you actually go here, you can see that the storage layer is one of the things that we want to set straight in the first alpha stage or the MVP stage, right? So this is the layer we are talking about right now. So revolves pretty heavily around creating the vault file. In this document, we are going to lay the foundations for storing the data. Now, this is something that I have decided upon early, and this is, I think, the third time or something I am repeating it, that Chamber, I do not want to use Chamber to encrypt raw storage media like USB drives or hard disks. I want to use Chamber only to create encrypted vault files inside which other files can be kept, right? So with this in mind, let's proceed. A rehearsal of requirements. So what all do I want to do, right? I looked at what I wanted, and I told myself, have you even thought what you're daydreaming about? Now, I do have a fair bit of idea about how file systems are created, although I'm not an expert. I know that there has to be a predefined space of a certain size. That size also is typically predefined. You need to create some area, if not multiple areas, where you're going to store special information. Usually, the special information is the index of the file system, the tree structure where they lay out the directories and their files and their inodes and the address on the disk in that space where everything is located, right? Super blocks, or I think it's called MFT, master file table in case of NTFS. Yep, and so on, right? So when you bring in splittability, that itself is a huge chunk of problematic parts of what I need to do. This is a good chunk of the set of problems that come up from a typical file system. If you want to implement a file system that is in the traditional sense laid out the way other file systems that an OS works on is laid out, then you have got a lot of problems on your hands. Anyway, let's go through it again. So I have to create a file system. This in itself is such a humongous task that it takes years for some of the greatest minds to get things right. Like think of ReaserFS or ButterFS or ZFS. These are fairly complicated projects. Even XFAT took quite a number of years to get implemented properly everywhere, right? So if you do not know about file system, creating one means that you have to deal with allocation of space when a new file is created or an existing one is expanded, deallocation of space when a file is edited to reduce the size or is deleted, creating an index for the files, ability to create hard links within that index, deal with durability and journaling requirements. So journaling in a file system is basically like what wall is, write ahead log is in a database or a data store of a different kind, wherein all the changes that are supposed to be in a file are first written to a separate place, and only when all those changes are written to the disk, they are confirmed and atomically updated in the index to mark the creation of a file and the modification or whatever was happening with the file, right? Ability to stream file data to an application. So let's say if you have a computer that has got 8 GB of RAM, but you're trying to play a movie file that's say 20 GB of size, you can't fit all of that data into RAM, right? So you stream data, you read data in chunks in a series of bytes, and then you feed it to your video player or whatever, and that's what I mean by streaming file data to an application. Then you need to be able to modify the file contents, be able to copy, paste, move files, and these are obviously going to have their own complications introduced into durability and journaling, how you're going to manage the links, and there is something called COW requirements. So if you say go on here and let's say you create a new file, let's go to here itself, right? If you go ahead and right click and say duplicate this, on Mac OS at least, doesn't matter how complicated and how big your folder structure is, it gets completed instantly, right? So if I go and say get file info, you have got how many files? Does it say files? 473 items, right? 478. I don't know how that increased, but fine. If I say duplicate, that's it, instant, right? And it will work like this. Doesn't matter how big a file or how many number of files there are already. So that is a COW, copy on write copy of the original, wherein the new folder that gets created, that duplicate folder, its items point to the same place as the previous ones on the disk, but if you modify something, then a new copy is created. That's what a copy on write is. So the second, this is the primary set of requirements. Then I want chamber files to be splittable. This alone started breaking my head when I stopped to think of how to implement it. I mean, if you are able to create a file system, which can span across multiple splits means you are reinventing something which can be done with RAID or LVM, and given the amount of bugs that can arise in these two systems, this is not at all easy, not even close. Okay, now we want it to be mountable, and in most cases mounting on a Unix like system would be easier as there are libraries that can help. However, mounting requires you to deal with inodes, permissions and other things, and mounting on Windows is something I don't even know. I mean, obviously it's possible and people do it, but I don't know how to do it, not yet at least. But we do not want to impose a file system. So we want it to be mountable, but we don't want to impose a file system. So if I go back to introducing Chamber and I come here, and one of the requirements, the feature set, it had was can mount, but mounting is not required. So I have to fulfill those, both of those, right? I cannot impose a file system. And one of the requirements of a vault created by Chamber, which will be called a Chamberfile, is that it's a typo. It should not impose a file system so that the cross compatibility could be guaranteed across various OSs, operating systems. Since I'm thinking of getting it to eventually work on mobile devices too, using an existing file system inside the vault would be impossible. That's because your iPhone, even if you're able to make Android work with an exFAT drive, because well, Android allows you to easily plug in devices, maybe your iPhones won't allow it. I have not even tried that, but yes, it can be problematic. exFAT file system is a good candidate, but I can't make it work. I mean, at least not with the requirements of splittability and durability, right? Durability is one of the biggest promises I want to make, something that a typical cross-platform file system won't be able to give. Durability in a file system is achieved using a journal, which acts more or less like a wall, which is write-ahead log, like I said just a few minutes ago. Journaling file systems are much harder than simple ones. Example of journaling file system would be ext4 or Btrfs, as in BTRFS, or NTFS. NTFS is one of the famous ones that does journaling, and they are all complicated. I mean, if you look inside what these file systems, how these file systems are designed, it's complicated, right? And to get all of this to work at a place, I mean, when I started writing the list of features that I wanted to implement, I didn't think of all of this. This is just a dream. I was dreaming, right? So this is the rehearsal of requirements. If you think back of the features that you want to support, I mean, I want to support in Chamber, this is the minimum that I have to deal with. Okay, now let's look at the constraints and the benefits. I was not supposed to be dealing with raw devices. That I have already made abundantly clear here, time and again. Instead, I had to create individual files. When you deal with raw devices, reading and writing to it from a file system perspective is a very critical task. But then I was not going to have to deal with that. I had to think more about how would the chunks of my vault file be cached in the OS buffer, rather than how do you bring in a particular cluster or page of data from disk to memory with reliable flush to disk operation. So my requirements, since I'm not dealing with raw devices, are a bit relaxed, right? I was supposed to think about how to save data coming from a plain text file into another file in a way that the offset could be recorded. I could make a separate area for index within that file, and when I say the file, I'm talking about Chamberfile, the vault. Since I could make it splittable, maybe I could also create a separate file for index. Now coming to encryption. I had thought of using AES 256 as the encryption mechanism. Now AES is a block cipher, which means that I can easily split any data into 256-bit parts and encrypt them and join them back into an encrypted file. Now, and join them back into an encrypted file, this is what happens anyway. So if I could split a large file with a predefined max chunk size, which is a multiple of 256 bits, then I could easily create splits, which each split containing a piece of a large file. So I want encryption, and I want the vault file, the chamber file, to be splittable. So this was something that I wanted to consider, and this creating chunks of data that are multiples of 256 bits and then doing an AES block cipher on top of them. And I've not yet decided actually whether or not I want to keep the extra parameters of that encryption with that chunk, or I should define them separately, keep it, universal across all the files. I've not decided any of that. Right? Can we use already existing tools? So encryption is nothing new. File systems are nothing new. Vault files are not new either. And everything that I need to do must have been done in one way or the other by someone else. And there must be some tools available, right? And a famous quote by Sir Isaac Newton comes into mind, that I was able to look so far because I stood on the shoulder of giants. He is talking about the research that was already done before him, which was useful for him to actually do his work, right? Most of software engineering is based on creating layers on top of existing stable layers. So we have gotten from punching holes on a card to writing binary to assembly to C to Java, and now we have enough technology to stare at beautiful unknown people trying to get more likes and views. I'm talking about social media here, right? All of this wonderful stuff that we have is layering, right? I mean, you have your hardware, and then you have your base layer operating systems, which are written in C, and then you have got other languages that are developed on top of C, and then you have got higher level languages, scripting languages that are built on top of other languages, and so on, right? And all of this networking and databases, they all stand on top of another stable layer beneath them, right? If, for example, there is no well-defined set of standards about how files are to be accessed, I don't think databases will be able to work, right? None of them will work. So it's about being able to build on top of already existing stable layers. So maybe something that already exists can solve this set of requirements, was my thought, and I wanted to look for it, but I didn't really search for it. And sometimes, as it happens, solutions show themselves just because your mind was looking for them, and they have been all around since day one. Or at least that's what happened in this case. I've been a full stack web developer and have almost always been back and heavy on the engineering. I had once upon a time imagined, like many others like me, that if I keep the user uploaded assets like images and attachments inside a database, then it would be so much easier to back up and restore. You just need one backup script and it will back up everything, and you restore the asset data, and it goes into the database. You serve directly from database, and it would be so easy, right? So back in my day when I was trying to create C integration, that idea came into my mind the first time. In one of my earliest projects, I actually tried it too, and I had actually tried simulating the folder-based structure. Yes, I had done that on my database. It was a Postgres one, using a couple of tables. And this idea was already in my head, sitting in a corner, and I didn't actively pursue it. So when SQLite got mentioned somewhere, yep, this is the solution. And I think it was on a blog post or a YouTube video, I don't remember right now. But once it hit my mind, I was like, okay, this looks like it could solve my problem, right? It's like a bulb glow over your head moment. So what does SQLite give me? It's a database. So I can express the index of files pretty easily, and it will be pretty fast to implement. Like, I don't have to write indexes from scratch. I don't have to create the B trees and all the traversal algorithms, or sorting and searching within that, rebalancing of the trees when folders get moved, renamed, destroyed, created, copied, any of that. I won't have to implement all of this, right? And I am not trying to build the most complex software in the world. I am trying to solve a problem. And this SQLite, being a database, allows me to create the file index pretty easily, and I can implement it pretty fast, right? And I'll be able to execute my set of requirements and verify whether they work or not much more easily than doing it myself, like creating the index myself somehow with using pages and everything. Now this is something that Postgres also taught me. Reading about Postgres internals also taught me how they manage indexes, but doing that is nowhere close to being easy, right? I would also be able to add new kinds of attributes much faster, because since it's a database, you can just create a new column. I would be able to search and filter files by any combination and filter over attributes of files without much work being needed. Again, database, right? Now SQLite is a file. SQLite databases are saved as single files. So if I can save data in and file index inside a single database, then it will all be saved together as a single file, which is one of the requirements that I have, right? It should be a file, a vault file. Now I can split it. I can easily create 2 or more SQLite databases in a folder, which I'm calling Chamberfile here. And with some clever data chunk rules and well-written code, I can maybe even create splits of the larger file into smaller parts, and can also read from those multiple database files and dump them into one to join them all back. I mean, it's like read from multiple SQLite database and create a bigger one when you want to join, and read from a big one and create multiple smaller SQLite databases when you want to split. So it makes it easy. In addition, SQLite databases work nearly everywhere. Windows, yes. Mac, yes. Linux, yes. They are also available on Android. They are available on iOS in one way or the other. Plus, they are understood by multiple languages. I mean, I don't think there is a practical mainstream language which doesn't have a support for SQLite. SQLite itself is has CLI based tools. You have got tools in various IDs, and there are like dozens over dozens of GUI software that can deal with SQLite databases. So if I implement chamber files as SQLite databases, not only am I solving the problem easy, I am also letting the end user have all of their encrypted data accessible to them very easily. If I implement my own file system layers and I create my own way of storing index in a tree and data chunks on disk, let's say something like a Lux container or a Veracrypt container, it's not very easy. I mean, it's nowhere close to being easy for any end user to actually use them without a specialized tool, right? That file system, whatever I could come up with, must be supported by the OS. But with SQLite databases, I mean, if I implement my chamber file as a SQLite database, I don't think there is a problem at all. Anyone can take up a free or paid subscription or go to the SQLite command line, and they can open this, and at a minimum they will be able to extract the the encrypted chunks of their files, and with some actually very little scripting, they should be able to write in any other language that supports SQLite, which would be most of the languages. They'll be able to just create a simple script that can extract the data and work with it. I mean, if you have your encrypted data with you, the only thing that remains is to decrypt it. And if you have your keys with you, if I tell you all the ways that I'm morphing your password to get your encryption key, then I don't think it's very difficult for anyone to actually read an SQLite database and get his data back, right? So this makes sense. Copy, paste, move, COW, rename, search, listing was all too easy to be done with SQLite, since it's all database operations, at least compared to creating a new file layout. All of these were SQL queries. With some extra word, I could handle durability without even enabling wall mode for SQLite. Why am I mentioning without even enabling wall mode is because walls are stored as separate files, and I do not want to create extra files except the chamber file for this vault. So even without wall, I can guarantee some amount of durability, right? Allocation now means inserting new rows in a file. Reallocation meant deleting new entries and asking SQLite to compact the database. And honestly, okay, let me complete this. So that's it. This is what I needed. The mounting would have to be implemented by me for each OS separately. And I guess you could probably implement a NFS or a SMB layer on top of this SQLite database, so that you could mount it as a network, a hostable solution, and it would still be readable, right, from across the network. That also, I have not written it here, but this solves that problem as well, being able to access it remotely. And that would be answer to most, if not all, of the problems on the storage layer. So one project which is open source, by the way, I'm talking about SQLite, which is open to view but not to contribute, with strict guidelines and promises, and it has a blessing as a license. Honestly, if you go and search for SQLite and you go to its license, I don't know where the source code is. I remember that part. Download SQLite source, maybe this, and save and open this. And if you go to license, look at the license. The author disclaims copyright to, so this is preliminary information, including all of the files and directories listed in the bullet below are public domain, and usually contain a header comment similar to the following. Author disclaims copyright to the source code. In place of a legal notice, here is a blessing. So you don't even have a proper license. It's a blessing, right? I remember this term. And if I go back, I guess this was the one, no, this tab, and with a blessing as a license. So that was my answer. This is what I would use for the storage layer, SQLite database. And that's it. That's what I'm gonna make Chamber as a SQLite database. And everything else is going to be built on top of it. I guess that solve most of it. All the problems that I have, obviously mounting will have to be done separately. Auto resizable, again, you put more data into SQLite database, the SQLite database file expands, and if you delete and say, hey, compact it, tell SQLite to compact that database file, it will automatically shrink. You can have splittable and joinable attributes. File system, obviously I'll have to implement. Hostable, just write some software on top of SQLite format and it becomes hostable. So yes, the data layer is more or less solved. And if you have any more questions, you can ask them in Discord here on techreel.in. Go to this place, Discord, and ask, or maybe put a comment on the video. Either way, that's it. Thank you for listening to me, and we will catch up in the next one. Thank you. Bye.